Okay guys, today we're going to look at how you can effectively balance a chemical equation. Alright, so to start off with, I'm just going to very quickly describe what a chemical equation is. So chemical equations are what chemists use in order to display a chemical reaction. On the left of a chemical equation, you have your reactants, and these reactants, they change into products via a chemical process. We always use an arrow in chemistry to show that a chemical reaction is taking place. We do not use an equals sign. That is frowned upon. Okay, so please don't use equals signs for chemical reactions. Always use an arrow. What that arrow means is that it reacts to make. So this reads as reactants react to make products. Please don't use an equal sign. So due to the conservation of mass, chemical equations have always got to balance. So what does that mean? Well, it means that you've got to have the same number of atoms on the left hand side as you do on the right hand side. So the same number of each a type of atom on the left hand side as you do on the right hand side. So for example, if I had this chemical equation here where sodium reacts with chlorine to make sodium chloride, I can see very, very quickly that I've got one sodium atom on the left and one sodium atom on the right, and I've got two chlorine atoms on the left and one chloride ion on the right. So this is not a balanced chemical equation. So we need to make sure it's nice and balanced. And the way that we make sure it's nice and balanced is essentially by using stoichiometry, which is essentially multiplying up reactants and products using large numbers in order to create a nice balanced chemical equation. So I'm going to show you now a method in which you can achieve this. So one way in order to balance a chemical equation is to try and visualize all of the reactants and the products inside their own little box. So here's how you go around it. Place each whole reactant into its own separate box. So I've got one sodium atom, I've got two chlorine atoms, and then you want to do the same for the reactants on the right. Place all of your reactants into separate boxes. And the way this method works is that you're only allowed to add whole boxes. You're not allowed to add half a box, a quarter of a box. You're only allowed to add whole boxes. And you just want to work from left to right in the chemical equation, comparing how much of each atom you've got, and then start adding boxes to try and get it so that you've got the same amount of each a type of atom on the left and the right of the chemical equation. So if I work from left to right in this, I can see that I've got one sodium atom over here and I've got one sodium atom over here. So right now sodium is nice and balanced. The problem I've got is I've got two chlorine atoms on the left and I've got one on the right. So that's a problem. So in order to fix it, I need to add one whole box. So now I've got two chlorine atoms and two chloride ions, and that's nice and balanced. However, the sodiums, I hope you can see, are not. So therefore I need to add an extra box of sodium. And if I do that, I've now got a nice balanced chemical equation. And we have to finish it off, so you have to now add in the numbers in order to balance the chemical equation up the top. So the number of the boxes that you've got is the number that you place in front of each of the reactants and products. So I've got 2 boxes of sodium, so that means I need to put a 2 in front of there. I've got 1 of the boxes of chlorine, so in chemistry we don't show the 1s, so you don't need to put a 1 in front of here. And I've got 2 boxes of NaCl, so I place a 2 in front of there. Okay, and that is now a balanced chemical equation. Let's have a look at another situation. So if we had aluminium reacting with bromine, if we go to AlBr3, you just want to apply the same same method. Place everything into a box. So we've got aluminium, we've got bromine, we've got aluminium and 3 of the Br atoms over here. Fine. So I now want to work from left to right. I've got 1 aluminium here and I've got 1 aluminium here. So that's nice and balanced. However, I've got 2 of the Br atoms on the left and I've got 3 of the Br ions on the right. So that's an issue. I need to try to balance it. So I need to start to add boxes to see if I can get this to balance. So I'm going to add an extra box here. So that means I've got Al, Br, Br, Br. I've now got 6 of the Br atoms and I've got 2 over here. So that means I can now add an extra 2 boxes here to get me up to 6. Br, Br. I didn't leave much room there for that box. We'll try to do better next time. Br, Br. I've now got, I hope you can see that, I've now got 6 here and 6. So that's nice and balanced, but the aluminiums are not. So I need to go back and I need to make sure that the aluminiums are nice and balanced. So there we go, I put another Al. That's a balanced situation. So now I want to go up to my equation and I want to put in the multiplying numbers. So I've got 2 boxes here, 2, I've got 3 boxes here, 3, I've got 2 boxes here, and that's a 2. And that's a nice, lovely, balanced chemical equation. And you can apply this to any chemical equation that you like. Let's look at one more. That's maybe a bit more tricky. I'm going to need to flip this around because it's got quite a few more things in it. So let's look at HNO3 plus MgOH2 goes to Mg bracket NO3 2 plus H2O. So same idea, guys, place everything into boxes. It takes a bit longer. 1, 2, 3. So we've got 1 Mg, 2 oxygens and 2 hydrogens. Over here, got Mg, 2 Ns and 6 oxygens. 1, 2, 3, 4, 5, 6. And then here we've got H and then an O. Okay. So now we just want to work our way through. Again, this is just working from left to right. And you might want to pause the video and try it yourself. It's up to you. I'm going to work it through now. So we've got 1 nitrogen over here. I've got 2 over here. That means I need to add an extra box because that's not balanced. Okay. Now the trick is always do the hydrogens and the oxygens last. That's the trick in these ones. So you want to go for the other elements and then you want to do your hydrogen and oxygen last. So magnesium here, there's 1 magnesium and there's 1 magnesium. Okay, fine. That's nice and balanced. I'm now going to look at the hydrogens. I've got 2 hydrogens over here plus another 2. So that's 4 on the left hand side. And there's only 2 on the right. So I need to add another box of this in order to get it to balance the hydrogens. And now I'm going to look at oxygen. So I always do oxygen last, and I would recommend that you do that because it makes your life a bit easier. So there's 3, 6, and 8. There's 6, 7, and 8. This is now a lovely, balanced chemical equation. So I put in my numbers. I've got 2 of those boxes. If we don't show the ones in chemistry, and I've got 2 here like that. And that is how I teach balancing chemical equations. And I hope that has helped you. If it has at all, please leave a comment. How do you like to balance a chemical equation? Please like and subscribe, and hope that your chemical journey is going well and that you're enjoying it. Okay, see you on the flip side.